Hi guys. All right, we're on to 17.3 here. So we're working our way through the periodic table in different ways. Okay. Um, we've worked through metals and nonmetals. And now we're going to kind of look at the columns of the periodic table. Okay. The columns in the periodic table are called groups. They used to be called families, and I kind of like that term because it kind of gives it the right idea. Um, because just like all the members of your family, um, they all the elements in a column are sort of alike. They kind of behave the same in certain situations and chemically. They sort of look related, they act related, but they're not all the same. Okay, so columns of the periodic table. Up. Didn't switch colors on me again. Make it switch. There we go. All right, so I'm starting all the way over on the left-hand side of the periodic table. The first column is called the alkali metals, or group 1. Okay, and the reason why they're called the alkali metals, alkali, Arabic, is alkali is an Arabic word for fire. Okay, how about if I spell Arabic right? Okay, so these elements are really very reactive. Okay, they react, super reactive. They react with air and water. Okay, they have one valence electron, and they're pretty much willing to do whatever it takes to get rid of it. Because if they get rid of their outer valence 1 electron, the shell inside of it is full, and that's stable. So they react with pretty much anything they can get their hands on. Okay, if you remember from the hunting elements video, which again, go watch it. There's a section where they take sodium metal. So sodium, it's sort of like the consistency of cream cheese, like it's cuttable like that, but it's shiny, it's ductile, it's malleable, it's all the things that a metal is. But it's kind of like the consistency of cream cheese. It's weird. Anyway, that sodium is so reactive that it is actually stored in oil, because if it was just in a jar, it would react with the air in the jar and explode. So they take sodium, the metal, they put it in a bowl, and they pipe in chlorine gas, which is also super duper toxic. Okay, and they heat it up a little bit, and that makes a reaction where they actually make table salt that goes onto a big can of popcorn. Okay, so it's really kind of interesting to watch, but these are all super duper duper reactive. They one valence electron. What else? They're all kind of soft metals, so they don't look like metals like you think, but they're all shiny and all those other things. Okay. All right. Next group over, group 2, the alkaline earth metals. Okay, so these are often called the earth metals because when placed in a fire, let me try that again, fire, they don't burn. So back in the day, they were called an earth metal because they didn't burn. Okay, these are also reactive because they have 2 valence electrons, and it's easy to get rid of 2. It's a lot easier to get rid of 2 than find the other 6 to fill that shell. Okay, these are not found as elements in nature because they're still reactive. Okay. Ugh. As usual, I can type awesomely. Okay. And they have 2 valence electrons. So if you notice, group 1 has 1 valence electron, group 2 has 2 valence electrons, group 3 has 3. Okay. So that's group 1 and group 2 on the left-hand side. Then there's that whole section that kind of sits down. Okay. Groups 3 all the way over to 12. Okay. So these sit a little bit lower in the periodic table. Okay. These are the Metals you think of when you think of metals. Okay. Iron, steel, or iron, sorry, let me try that again. Iron, gold, silver, nickel, all of those things that you picture as metals, they're all transition metals, okay? And the reason why we call them transition metals is because they gradually change as I go across, okay? From group 3 to group 12, okay? They sort of lose their metallic properties, okay? We are not going to spend a lot of time on this group because there's some really funny chemistry that happens when you get to actual chemistry, probably in 11th grade. You'll spend more time on this group because they're super important to our lives, but they don't follow the basic patterns. There's some different patterns you have to learn. Okay, so now we're over the kind of lower set part. We're over onto group 13 through 16. Okay, and we call those, and this is the part that sits high again, we call those the mixed groups because they all contain more than one kind of element. Okay, so they contain metals, try that again, non-metals, and metalloids. Okay, it doesn't like when I put a thing in there. Okay, so these groups are kind of mixed and there's not a lot of pattern to them. Okay, they're usually named for the top element. Okay, so group 13 has 3 valence electrons. It's called the boron group. Okay. Group 14 is called the carbon group. It has 4 valence electrons. Group 15 is the nitrogen group. Has 5 valence electrons. And group 16, oxygen, has 6 valence electrons. Okay? Do you see what the pattern is there? It's kind of beautiful. All right. Group 17 is called halogens. Oh, let me make this blue. This group is also really important, and it has a name, so obviously it is. Halo is salt. So this group of elements, which is group 17, so there's one more column over. Group 17 is very, very reactive. Okay. They're all nonmetals, so most of them are gases. They're all very colorful. So like chlorine is this yellowish greenish color, bromine is this brownish red color, iodine is purple. They all kind of have this colorful thing going on. They're all toxic to humans. Okay, so like in bleach, the thing that kills things is actually chlorine. Okay, if you go for surgery, they clean your skin with iodine, again, kills the bacteria. Okay, they have 7 valence electrons. Okay, so they act like bullies to steal the one electron that they're missing to fill their shell. Okay, so when we find them in nature, they actually form bonds with each other. So like chlorine gas is actually Cl2. Okay, table salt, the stuff you put on your popcorn, see this popcorn, see salt, that is sodium chloride. Okay, so the chlorine steals the sodium's extra valence electron. Okay, what else do I need to put there? I think that's it. Okay, noble gases is the very, very last column. Okay, they're called the noble gases. Again, if you watch the video, highly recommend Hunting the Elements, worthwhile. They're called the noble gases because they don't hang around with the riffraff. Okay, so this is the last column. Okay, their valence shell is full, so they don't form bonds. Or compounds in nature. There are some scientists that have figured out ways to make them form bonds, but it's kind of a force thing. Okay, so these are super stable. Okay, they don't react, they don't need anything. Their valence shells are very full. Okay, all right, that brings us to the questions. If you notice, I stuck them all here. Your questions are 1 through 7. Again, they're graded on effort. So read the question, give it a shot, do your best work, and you'll be successful. Bye, guys. Have a great day. Miss you.